Okay. Hello everyone, my name is Ijlal Ahmed and we're the team Karankokatu and we're dealing with the waste management of Shalafti municipality. This is the outline of our presentation. We'll be introducing this whole scenario, the problem, the users in our scenario, and finally the architecture we propose and some of its features. So, with the increase in the world population and with the concentration of a huge part of that population moving towards bigger and larger cities, waste management, its collection is becoming more and more of an issue. And it is becoming difficult for the collectors. Sometimes they have to, depending on the amount of waste generated and its concentration, they have to move out to collect it multiple times a day, and that results in inefficient use of the resources and such as fuel. And our aim is to solve this in terms of the scenario of Shalafti municipality. As I said, one of the major problems is to prevent the waste collectors and managers to not use the routes that are inefficient, so that they don't go about city collecting waste that is not at a certain level to be collected. And we want to provide them with efficient routes so that they can use their resources, namely their fuel, efficiently, which would save them money, and also it would be more sustainable. Apart from that, we want to increase the quality of the surroundings. So we want to check and know the level of the trash that is in the bins, so that it might help the people and the collectors, that it doesn't overflow, it doesn't generate bad odor, and yes, these types of issues. The users that we have mainly identified in our scenario are, one, the municipality or the waste collectors that will be responsible for going out and collecting the waste. And the second ones we're aiming for the average citizens, so that they can use our solution to get information about the status of the bins and the trash which are available to them nearby.
Okay. So in designing our architecture.
Speak out. You just can use.
So in this slide, I would like to present the architecture of our system. What we designed so far. It was given to us that this system ideally is supposed to work over the SSIO platform, which I suppose all of you know. That it has been already launched in Shalefti, and there are some pilot projects and sensors attached to it. In our case, we would use the sensors over there that you see attached to bins, and they would give us information about the current level of the waste in the bin. The sensors are connected through the LoRa network, and that's it about the hardware installed in Shalefti, ideally. As for the software and what we were mostly focused on, for now we implemented it as a web application, and the technologies we used are Python and Flask for the web, MongoDB, JavaScript, and the special thing that we're using are Google OR tools, which is a library with a set of tools for optimization and constraint problems. So how would this system work? For now, with what we tested so far, the sensor would send data to the server, to the SSIO server every 4 hours, indicating the bin level and some other additional data related to the sensor. Given that, we plan that we will collect this information for all the bins that are placed in the Skellefteå municipality. And every day, maybe at the beginning of the day or a suitable hour, we would see which bins are full enough for them to be emptied and considered in the planning process to be collected for that day. So how would this work is that the waste management company, based on the area where the bins are placed or on other factors like special events or season of the year, would set some sort of threshold for the waste level in the bin, so that if that threshold is passed, this bin will be considered for collection. Now, we're putting this threshold as a safety measure in order not to empty a bin too late when it's already full or when waste is all over the place. And except that, even users, normal users, citizens, can report if some bin, even though it's not empty, there's something faulty there that releases a bad smell or something like that. So users can report it in order for that bin to be served immediately with like in an urgent. So yeah, every morning the drivers of the trucks will be presented with their optimized, calculated route for collection. Oh, and something else regarding, so this solution would be mostly beneficial when we're considering separated waste, because as we know, some certain trucks can either carry two or more types of waste. Some trucks are really specialized, and for example, for less occurring types of waste like glass or paper, or it might depend even on the time of the year. You might not need to send out trucks for collection like in 2 weeks or more. So in this way, the savings would be really high on fuel.
In terms of our business model and the opportunities that our solution can have, it is mainly addressed for the municipality or the people, which normally is the municipality, who are responsible for collecting the waste and managing it. So our solution for them gives them some savings in terms of maintenance, human resources, and natural resources. Because if you save, first of all, if you efficiently send your vehicles to collect garbage, you will save on fuel. And at the same time, you can employ less resources in terms of the employees that you use, and in terms of the vehicles that you use, because you don't need to send out multiple vehicles at different routes for the trash to be collected. You can optimize that and use a certain number of vehicles. And if this solution is applicable and successful in a smaller municipality like in Skellefteå, it can be expanded to other cities. And in terms of the life quality of the people, we can use this because it has an aspect or it will have an aspect of user feedback, and people can know the status of the waste around them, and they can also report. So it can be used as a platform to improve their recycling habits, and yeah, it can be used to improve their recycling habits and in general their life quality, because we can this platform can incorporate more information for them in this regard. In terms of because we worked on it mainly as for a prototype for this hackathon, but some of the features that we thought that might be able to be incorporated in the solution are the admin features. So the application can have an administrative panel, which would be for the waste management company, and they could change, as Ursula mentioned, the thresholds regarding different in terms of different seasons and times. Data analysis, because once the solution comes into effect and you have a certain data of the trash that is generated and placed, you can analyze that data and apply some tools such as machine learning to better improve and optimize the routes, because one of the suggestions by the jury was that if there is some bin with some trash that is not over the threshold but it is in the way, then that could also be incorporated. And this solution could be improved step by step with the data. The sensor, it provides some other data apart from the level of the trash. It also provides a humidity level and some indication and trigger for the temperature to prevent fire. So, and also it gives some information about the level of the bin, if it is about to fall or not. So these information from the sensor can be used to implement some other feature. For example, if depending on the humidity, the bio-waste would release more or less odor, and that could be incorporated while collection of the trash. And yeah, and to optimize the placement of the bins, once you have some data and once you perform some analysis, you can, the waste collection company or the municipality can place bins according to the routes that show that these parts of the city produce more trash and more waste. Now we would like to show the working application.
So this would be like the first interface that the management company would see, and behind this we have a database with all the bins and all the trucks configured. In this scenario, we're considering like 20 bins located in Skellefteå, and we're considering 3 trucks of capacities like 10, one truck of capacity 10 meters cubes, and 2 trucks with a capacity of 7 meter cubes. So now I'm going to generate the routes and with the latest data from the sensors. So this is the view for the ideally for a truck driver, and they would see the routes that they have to. They would see the routes that they have to go through during that day. Okay, so this is the first route. Apparently, the route for truck number 1 is nothing, so it shouldn't go out in the city to collect waste. And this is the route for the other truck of capacity 7. As you see, this point here is the recycling facility, the place where the bins are emptied every day. And except that, we also have some interface for the user to allow them the reporting. Here, the users can view all the bins, at least the bins that we're considering for this prototype. If they click on it, they can get information about the type of waste and the current level of that bin, like for example 91%. And if they would like, or they notice something, some bad odor or whatever, they can report this bin for it to be considered like to go in an urgent queue so that the truck can visit it the next day.
Yeah, so this is more or less our running prototype, and yeah, the colors here signify the different type of trash. The blue is the general one, the green is the bio waste, and if you want to put it gray or around there, which was negative. And for this prototype, we just placed the bin randomly across the map of Shillelagh, some in the city center, some in the campus area, and some around Shillelagh. So that's it for us. If you have any questions, please let us know.
Any questions?
Regarding the sensor you are using, let's say you showed an example, the type level is 91%.
Yeah.
So I'm just wanting to know 91% of the weight capacity of the bin, or
No, it's not the weight, it's the volume of the bin.
so there is a camera, or how do you, I mean?
The sensor is just a level sensor. I think it kind of sends some signal to measure the distance. I don't know exactly the technology that it uses, but it measures the level of the waste.
We don't exactly know the specifics of its working, but it gives you the height of the trash that is inside the bin. And depending on that height and the dimensions of the bins that we calculated the volume. We took some dimensions from the internet, from some websites that sell them, and based on that, we generated the volume. And that 91% shows you that this, with regards to volume, the 91% of this trash bin is full.
Any more questions? If not, thank you very much.
Thank you.